Okay, so here we shall explain one example on the concept of the definite integral as a limit of sum. So if it is asked to evaluate the integral 0 to 2 e power x dx as the limit of sum, so then so the formula or the definition, therefore the definition of the definite integral as a limit of sum, integral as a limit of sum is given as integral a to b f of x dx, that will be equal to limit n tends to infinity b minus a by n, then summation r goes from 0 to n minus 1 f of a plus rh, which means that we can write it as b minus a into limit n tends to infinity 1 by n into f of a plus f of a plus h plus dot dot plus f of a plus n minus 1 into h. Okay, so therefore here here the function that is given, that is e power x, and the lower limit of the integral, which is a, that is 0, and the upper limit of the integral b, that is 2. So therefore integral e power x dx from 0 to 2, that can be written as so b minus a, here h, here actually h should be equal to b minus a by n. Okay, so here so b minus a by n, that will be equal to 2 by n. So b minus a is 2, so we can write it as 2 into limit n tends to infinity 1 by n into f of a. So it will be f of 0 plus f of 0 plus 2 by n. So this is h actually, plus f of 4 by h plus dot dot plus f of uh, 2 into n minus 1 by h. Okay, so this can be written as 2 into limit n tends to infinity 1 by n. So f of 0 means x equal to 0 you have to put. So this is e power 0 plus e power 2 by n plus it is e power 4 by n plus it is e power 6 by n plus that will be e power 2n minus 2 by n. So e power 0 will be 1. So now we can see that this is a sequence which is forming a geometric progression. It is a GP where the first term a is 1. We can call it as a1. A1 is 1, and the common ratio, which is r1, that is e power 2 by n. So therefore we can say it is equal to 2 into limit n tends to infinity, which is so it is 1 by n into is 1 plus e power 2 by n plus e power 4 by n plus dot dot till e power 2n minus 2 by n. So here there are n terms here. So therefore this will be equal to 2 into limit n tends to infinity 1 by n into a into r power n, a into r power n minus 1 by r minus 1. So n and n will cancel. So this is equal to, so this is 2 into limit n tends to infinity e square minus 1 by n into e power 2 by n minus 1. So this can be written as e square minus 1 by limit n tends to infinity e power 2 by n minus 1 by 2 by n. Since here it is 2 by n, so we can write this as by 2 by n. Okay, so then we know that limit x tends to 0 e power x minus 1 by x, that is equal to 1. So this will be e square minus 1 by 1, which is e square minus 1. So this is the answer. Thank you.